And then I'll go over this example here. All right. I guess I'll back up a few slides. So we were talking about if statements and how to write these conditions. What's going on here? Okay. The if statements in Bash, the condition is a bit strange because the condition's actually a command, is the result of a command. Right now, remember the way Bash works is it looks at the exit status of this command to determine whether or not to execute the code in the if statement. Right. So if the exit status of that command is 0, then the code in the if statement will run. If it's any non-zero value, then the code in the if statement does not run. You can also use the double bracket, right? So you can use single brackets or double brackets. They have slightly different. They do slightly different things, right? So the double brackets suppress word splitting, so you don't have to worry about quoting variables inside double brackets. So the double bracket notation is a little easier to use most of the time. And then there are these integer conditions as well, right? So for the integer conditions, you write them inside double parentheses. And this is probably the form of the this is probably the test you should use for when you're comparing integer values. Right. Now, what you have to remember is that the integer values, when you're using the integer test, you have instead of using the exit status, right? It's a numerical test inside. Right? So there's no command in this case, right? You're simply comparing the result of an integer expression. Now, instead of the exit status being 0, right, for this part of the if statement to run, the numeric value here, if it's non-zero, wait, did I fix expressions that evaluate? Right. If it's non-zero, then it's true. Right? So that's considered true. Right. So any expression that evaluates to 0 is considered false, and any non-zero expression is considered true. Right. So that's opposite the way that the regular if statement works. Right. So when you look at an exit status, 0 means true and non-zero means false. When you look at a numeric value using the round brackets, 0 means false, non-zero means true. I suspect this is because they're trying to be consistent with the way C works. So in the C programming language, true and false are represented by non-zero for true and 0 for false. Right, so this is consistent with the C programming language. If you actually run this, right? So if 1, then echo true, right? So if 1, then echo true. So 1 is a non-zero value, so that should evaluate to true, right? So in other words, this should print true, and it does, right? The numeric value is 0, then that should be false. Right, so this should not print true, it should print false, and it does. Right. Now the numeric, using the round brackets to test integer expressions, I think it's easier to use the round brackets than it is to use the square brackets and a comparison like EQ or NEQ or LT or things like that. Right. Especially if you're coming from Java, especially because you're coming from Java and Python. Right, so here I can use the double round brackets to look at the number of input arguments. Right, sorry, the number of command line arguments. Right, so if the number of command line arguments is 0, right, then we're going to exit with a value of 2. Right, so is supposed to exit with 0, with an exit status of 0 if the argument is even. Right? So if you pass in no command line arguments, this is going to return this is going to exit with a status of 2, right? Skip over this part here. I'll get to this in a second, right? Test if the number is even. You're going to compute the remainder with after dividing by 2, and check if the result is equal to 0, right? So this is just the standard. This is the standard test you would, the standard expression you would write in Python or Java. Right. So if the number's even, exit with 0, right? Otherwise, exit with 1. So otherwise, exit with a non-zero value. Let's ignore this for now and just see if this works. So this is even 3. Is even 3. Okay. So if the number is even, so 10. And this thing is supposed to exit with a status of 0, and it does, right? So remember $? That's the exit status of the previous command. If it's odd, so 99, it should exit with a status of 1. It does, right? If I give it no command line arguments, it should exit with a status of 2, and it does. Oops, sorry. Now, what happens if I type in a string? Right. So what happens if I use this script incorrectly? So I type in some string like that. And in this case here, that's not supposed to happen. Is even 3. Where's did I not? This was working just a second ago. Hang on. Code is 3. There we go. Oh, right. I was messing around earlier to test something. Okay, so that's what the code actually looks like. Okay, so if you type in a string, this particular script actually reports an error message back to you. Right, so it says the argument is not an integer, which is nice, right? You want to do input checking when you can. Now, let's see the code in this. The code that does the error checking is very strange. Okay, so let's take a look at what's going on. To test if the argument is an integer, I'm using this strange expression here. So I'm using the single square bracket for the test command. Right? Now it's important that it's the single square bracket here. If you use the double square bracket, this actually doesn't work. So if we use the single square brackets, then we have this following test, right? Now this is val eq val, which if you go back to the slides here, right? You use EQ to test if 2 int values are equal. So if that's an int and that's an int, right? Are they equal? That should return true, right? And now back here, right? So if not, so this expression, if this thing here is not true, right? So that's what the exclamation mark means. And it's going to output this argument. It's going to output this error message here. Now, why does this work when I pass in string? So this will always be true if val is an int, right? So some int equals itself. The answer is always true, right? So when you negate that, that'll be false, and so it will never print out this error message if the inputs are actually ints. Now it turns out that if these are strings, right? Who is the I guess it's the operator that you use to compare int values. One of these is a string, and you use EQ. Then in the current version of Bash, that's an error, right? So that's how this test is working, right? This evaluates to an error, right? And if you negate an error, as it turns out, right? So if you there's some error here, then it turns out that's true. And so this part ends up being output here. Now, you shouldn't do this, right? So this actually works in the current version of Bash, but it relies on an undocumented feature of Bash. In particular, it relies on the fact that this causes an error. So you should generally avoid doing this, right? So what I'm really trying to test here is the input argument an integer? And so the way you should test that is using a regular expression. Now, there's a few other things I should talk about here. The code that's here and the code that's on my editor is slightly different, right? So the code that's here, I've got the code in my editor, I've got this funny thing here. So let me delete this here and I'll explain what this does in a second. Okay. So this is the code that's actually on the slide. If you run that code, right, and pass in a string, then you don't just get this message here. Right? Instead, what you get is the following. Right? Instead, you actually get the error message. Right? And so now you can see that that expression is actually leading to an error. Right? It's saying that on line 8, right, when I'm using the test operator or the test command, right, the value of the variable is actually a string when it's expecting an integer. That's what happens when you run the code that's on the slide. Now, if you don't want to see that error message, right, remember that this is all a command, right? So when you run the command, if there's an error, it sends its result to standard error, right? If you don't want to see the error message, then you have to redirect standard error somewhere so that the message goes away. Sorry, Control V. Oh, sorry. Oh, nuts. Oh, sorry. Not here. Not here. Where's code? And not that one. There. Didn't I? Oh, I guess I deleted it. Okay. So what on earth does this do? All right. So that's the redirection operator, right? So to, right, followed by the greater than sign, is saying redirect standard error to somewhere. So I'm redirecting standard error to this file called root dev null. Right? So there's actually a file called null in this folder called dev, in this directory called dev that's in the root directory. Right? Root dev null, that's the device that corresponds to nothing, more or less. Right? So if you send output to dev null, it just goes away. So it just goes into the void, right? It disappears. So this redirects the error message to nowhere, right? So the error message doesn't get printed anywhere, which is probably what you want in this case. So now when you run this, you no longer get the error message, but the stuff in the if statement still executes, right? So you still get the argument is not an integer message, which is probably what you want, right? So there's actually a few things going on there. There's the redirection to root dev null, and then there's this unusual construct to test if an argument is an integer value or not. Now, the reason I'm doing that is because this is an example of using a test command to do something, right? Which was what we were talking about to begin with. Now, to do this correctly, you ought to use what's called a regular expression. Right? So you'll see why now I avoided using a regular expression, right? Because I have to tell you a bunch of stuff now about how to use regular expressions. So that's a nice segue into this topic. So a regular expression is often you just see the term regex. Okay, it's just a sequence of characters that specifies a search pattern. Right. So in other words, it lets you define patterns which specify strings. The idea actually comes from theoretical computer science and formal language theory. right? So it's an example of something that came out of theoretical computer science that actually had a really powerful application in programming. So you can use a regular expression when you need to search for text that matches a pattern. Right? So when you're trying to do some sort of pattern matching, regular expression, you can consider using a regular expression. What you have to be careful about you have to avoid thinking that you can use a regular expression whenever you want to search for a pattern, right? That's actually not true. Bash uses something called the POSIX extended regular expression syntax. All right, so how do we use a regular expression? So the following if statement will test if the string str matches the regular expression re. Okay, so re is a string, str is a string, right? Does the string match this pattern? Okay, and if it does, so in this if statement, it'll print out, yes, it does match that pattern. Otherwise, it'll print out it does not match that pattern. Right, so it's this funny equal tilde. All right. Here's a simple regular expression tester. Right, so I'm going to the way you run the script is test regex.sh. Right, and it's a string, and then it's a regular expression. Right, so there's your the name of the program. Oh, that should be test regex.sh. Does this string match this regular expression? And so that's the if statement that's on the previous slide. Right. Oh, that's not necessary. Sorry, I should get rid of that because it's doing something you shouldn't do. Where to go? Sorry, on this slide, you don't need to quote $1 and $2 because they're on the right-hand side of the assignment. Right? You don't have to quote on the right-hand side of an assignment. So if I'm just assigning a variable to another variable, you don't have to quote the variable on the right-hand side. So there's your little program. So we're going to use this program now in the following examples. So let's run the program a couple of times just to try it out. Make sure it's here. So there it is. Oh, I should point out another thing too. I just noticed this. If you're in code and you ever see a square that looks like that, like so it's you have what looks like to be a space, but it's actually shaded in. Code is trying to tell you that this is a non-printing character that's actually there. So it's a character that code doesn't know how to print. In this case, this turns out to be a non-breaking space, right? So this comes from the fact that I copy and pasted this code from the PowerPoint. In PowerPoint, so the PowerPoint program will often insert unusual characters into the code, into the text, right? So something that looks like regular text in PowerPoint often has a bunch of formatting characters. You can see there's this little symbol here indicating that there's a bunch of unusual characters here, right? So that thing there is a non-printing space. It really ought to be just a plain old space. If you ever see something like this in code, you should pay careful attention to it. Because if you had one of these spaces, I'm going to copy this and stick it somewhere else. So for example, I'm going to replace that with that. So if you ever see that, then you have to, there's a good chance that this script is not going to work, right? Because that's not a space as far as Bash is concerned. It looks like a space in code, right? So it looks like there's actually a space there. It's not, right? It actually tells you if you hover over it, right? So code tells you that there's one non-breaking space here. So if I run this program, that's ABC. So I'm going to test, does the string ABC match the string ABC? This should be true. But here you get a syntax error. Right, so it's complaining on line 11. Right. On line 11, there's an unexpected token near then, which doesn't really help because the token's in the front actually. Right. So here you get a very confusing error message. The error message is caused by the fact that this is not a space. It's not a real space, or it's not a character that Bash considers to be a space. Right. So that's a PowerPoint thing. You have to watch out for that. There was a research paper published a few weeks ago describing a bunch of security vulnerabilities caused by characters like this in code. So it turns out you can embed these unusual characters in code that can cause your code to do things that you don't expect. But anyway, that's an aside. So whenever you see something like this, watch out. Right? If you're copying and pasting code from the PowerPoint, it may not work. So watch out for that. Okay. Does the string ABC match the string ABC? The answer is yes, right? Does the string ABC match the string XYZ? Going to be no. Right? Now, that pattern and that pattern, those aren't very interesting, right? So the regular expression ABC only matches so the only string that matches that is the string ABC, right? And the only string that matches that is the string XYZ. So to write a regular expression, usually it involves a bunch of these, what are called meta characters. Okay, now when you're writing a regular expression, right, you have to remember that the regular expression meta characters are not the same as the wildcard characters that Bash uses for path name expansion, right? So the star in path name expansion will match any file name, right? That's not what it means in a regular expression, right? The question mark matches in a path name expansion matches any single character, right? That's not what it means in a regular expression, right? So the context matters when you're determining the meaning of star and question mark. So in a regular expression, the caret, which is Shift-6 on your keyboard, is called an anchor, right? $sign is also an anchor. Oh, notice that the $sign is also used as a meta character in a regular expression, right? So the $sign inside of the $sign in Bash, right? Usually you're using that to access a variable, the value of a variable, right? Now in a regular expression, it's actually an anchor, right? So if you have a caret, then that matches the beginning of a string when that appears as the first character of a regular expression. The $sign matches the end of a string when it's used as the last character of an expression. Here's an example. Okay, so if my regular expression is hello, right, it turns out any string containing the substring hello will be matched. So, if that example is correct, right, then ABC matches ABC, right? But that string should also match that regular expression. Does it? Yes, it does, right? Boop, boop, right? So when your regular expression is just a plain old string, right, that's testing, is that a substring of the other string, right? So the answer is yes in this case. So we get true, or we get the output of the program says that that matches ABC, right? Now that's often not what you want. Well, sometimes it's what you want to do, right? But if you wanted to test, does your string start with ABC, right? Then you would use the caret. So that says, does the string start with the string ABC? So this should be no, right? I remove the 1, 2, 3. It should be yes. So yes, that does in fact match that regular expression. The $sign means, does the string end with ABC? So the answer here should be no. Oops. No $sign. Oh, wait, that's right. What happened there? Usage test regex. Do I have to quote that? Oh, wait, I'm sorry, I'm a dummy. Hang on. There. That's what you want. So the, sorry, the dollar sign is a, it has to be at the end of the regular expression, right? So does the string end with ABC? Get rid of the 4, 5, 6 and put back in the 1, 2, 3. Now it's going to be true, right? So does that string end in ABC? Yes, right? If you want to test if a string exactly matches a regular expression, then you have to use the caret and the dollar sign. All right, so that's going to be false, but this will be true. Okay. Oops, sorry. The period matches any single character, right? Inside the regular expression, period will match any individual character. So if I change the B to a period, right, this asks, right, does that string contain any sequence that's A followed by anything followed by C? Right. So there's ABC. So that should return true. Right. I can change the B to anything, and it should still match. And remember, this is a substring comparison. So if there's anything in front or behind the A8C, it will still match. The bracket expression. So square brackets lets you list a bunch of characters inside the square brackets. Right? And so the regular expression will match any single character inside of that square, any one of the elements that are inside the square brackets. Example. Right. So suppose I want to match. I want to find to test if a string contains the sequence A followed by any digit followed by C. Right. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Let me get rid of the 3, 4, blah, blah, blah in front. Right. So this will match A0C, right? A1C, A2C, A3C, and so on and so on, right? So this should be true, right? That's not an 8. If that's not a digit, so if it's a capital letter, for example, that will be false. So this lets you define a set of matching characters. You can negate that set. So if you put in a caret as the first character inside that inside the square brackets, then that will match anything that's not inside. Change that to not. Now this will match anything that's not a digit, then C. Right? So this now will return true. Right? And if I replace the A with a digit, it's going to be not. It will not result in a match. All right, so let's look at these examples here because these are all using the dot, the anchors, and the character sets. What do they call them? The bracket expression. Right. So these all use an anchor. So these are all use the anchors at the front and the end of the string. So these will all do exact matches only. Right. These won't do substring matches. So match anything, right? Followed by ELLO. Right? Anything, anything, LO. Right? S, then A, then T, S, then E, then T, S, then I, then T. When you use the bracket expression, right, you're allowed to use a hyphen to indicate a range of values. Right? So A through Z means this will match S, followed by any lowercase letter, followed by T. you want to match the hyphen, right? So if you want the hyphen to be part of the character set, it has to be at the front or it has to be at the end, right? Can't be anywhere in between because then it looks like a range. So you have to be a little bit careful about that, right? So this is exactly the same as this, except it also matches S-T. If I want to find all the files that end with a digit, if I want to match all strings that end with a digit and start with the word file, right, I can use the range 0 to 9. The bracket expression lets you match the period. Right? So if I want to explicitly check for the period in the regular expression, you put the period inside of the square brackets. Right? You can't just use the period on its own, right? Because the period on its own matches anything. If you want to force the match to the period, then it becomes part. Then it's a single element bracket expression. Okay, these ones are now using. These examples are using the quantifiers. So let's look at those. So ignore the sub expression for now. Star, question mark, and plus, and this funny notation here. These things here are called quantifiers. Okay. Star means match the preceding element 0 or more times. Okay. Question mark is 1 or more. 0 or 1. Plus is 1 or more. All right. We'll come back to this in a second. Right. So star 0 or more. Question mark 0 or 1. Plus 1 or more. Okay, so dot means match anything, right? Star means 0 or more of these, right? So 0 or more of the characters in front, right? Dot star means basically means any string, right? So this will match the empty string, right? Because remember, dot means 0 or more. So it'll match the empty string and every other string, right? Because we have 0 or more occurrences of anything. Change that to a plus, that's 1 or more occurrences of anything, right? So that's every non-empty string. Question mark, remember question mark means 0 or 1, right? So if it's 0, 0 of anything is the empty string. 1 of anything is every string of length 1. Those are the quantifiers. We've already seen this, right? So we've seen the bracket expression. So 0 through 9 means any string containing at least 1 digit. Plus sign, right, means applied to the front, right? So the plus sign affects the thing that's in front of it, right? So it affects, in this case, it affects the bracket expression. So this will match any string containing at least 1 integer value, right? Containing at least, that's not, any string can, yeah, any string containing at least 1 unsigned integer, that's right. Unsigned. Sign doesn't actually matter here because you can't have a negative sign. So plus means 1 or more, right? So any string containing 1 or more digits, right? A sequence of 1 or more digits. Actually, let's look at that one. So we want to use this thing. My regular expression is going to be 0 through 9 plus. So does the string ABC contain a digit? Nope. Right. Does ABC 0 contain a digit? Yes. Right. Does it contain a sequence of digits? Right. So this is 1 or more. So 2, 3, 4, something like that. Still yes. Right. Like that. It's still going to be yes. So what this regular expression is not doing, right? It's not checking if the string contains only 1 sequence of digits. right? So there's your sequence, right? This one actually has two different sequences of digits, so it's not checking for that, right? If you want to check if it has exactly one sequence of digits, you need a different regular expression. That's the problem with regular expressions, by the way, is that often a regular expression will match more than what you really want. Okay, how about any unsigned integer? Right. I use the caret and the dollar sign. Remember those? So these are anchors, right? So the beginning of the string, right? The beginning of the string must match a digit or one or more digits, right? And the end of the string must also match one or more digits, right? So this is how you would match any unsigned integer value. Want to match a negative integer value, then you put the negative sign in front. So starts with a negative sign or a hyphen, followed by one or more digits, and then it ends. Close. So my regular expression, I'm going to put the anchors in. So there and there. Should match a number like 1, 10, right, or 1,000. It will not match negative 1,000, right, because of the anchor. Right? So the anchor says that the next character has to be a digit. Right. This also will not match anything with spaces in it. Oh, sorry. I have to quote that. Right. So it won't match anything with spaces in it or any other character. The other one, so if I put the minus sign in front, this one will only match negative integer values, right? So negative 34. But it will not match positive 34 anymore. Now, if you want to match any signed or unsigned integer, right, then you have to use the following, right? So now it's going to start. Now remember, question mark is 0 or 1. So there's either a minus sign, plus sign, or nothing, right? Minus sign, plus sign, or nothing, followed by an unsigned integer. So that's how you match any signed or unsigned integer value. Okay, there is another way to match just a digit, right? So to match just a digit, you can use square bracket, the double square bracket. Sorry, single square bracket. Single square bracket, colon, digit, colon, single square bracket. So this is, oh, I didn't tell you what it was. That's one of the predefined character classes. So you can use that notation as well if you like. All right. Any questions so far? So the regular expressions, it takes you have to practice them a lot to get good at them. We're not going to use them a ton in this course, but we are going to use them a little bit. So it's important that you actually get used to this syntax. The braces. So the brace is another quantifier, right? So m comma n means match the preceding element at least m times, not more than n times. Okay? And the n is optional, I believe. I don't know if the m is optional or not. Yeah, the n is optional. Okay, so xa, so starts with xa, right? There's a 1 here inside of the braces. So that means there has to be exactly 1a, right? So it only matches the thing in front of it. So it only matches the a in this case, right? It does not match the 1 does not apply to the xa, right? It only applies to the a. If there was if the a was a square bracket like 0 square bracket 0, 9, then the 1 would apply to the square bracket 0, 1, 9. So that's x followed by exactly 1a. This is x followed by 1, comma, nothing. So this means 1 or more. Right? So this is x followed by 1 or more a's. Right? You could use the plus sign here instead of brace 1, comma, brace. Here is x followed by 1, 2, or 3 a's. Okay. It'll match all of those. All right, now, this one applies to the thing in front. Right? So in this case, it only applies to the a. What if I really wanted it to apply to the xa? Right? So that's when you can use what's called a sub-expression. So that's when you use the round brackets to group things together. Right? A round bracket ABC, that's just the regular expression ABC. But when you modify it with the quantifier, so plus means 1 or more. Right? So this means 1 or more sequences of ABC. Right? So it'll match ABC, 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 or 3 ABCs. If you want the quantifier to apply to a group of things, you put them in round brackets. Okay, so going back to our is even example, right? So the correct way to test if an input is an integer value is to use a regular expression in this case. So you have to use the double square bracket. Is that true? I think you have to use the double square brackets to do regular expression matching. Right, so it's double square bracket, full tilde to do to force regular expression matching. Right, that's the regular expression for a signed integer value. So that's how you check whether or not the argument really is an integer. That's the better way to do it, right? Is to use a regular expression in this case. So you should avoid using the single bracket val equals val syntax. All right, there are some other. There is another another meta character that you can use. It's the vertical line. The vertical line is the choice operator, right? Basically, it's or. So it lets you match the expression before or after the operator. So here I've got starts with and ends with. It either starts with B, right? Starts with a B or a C is how you read this, right? B or C. The thing that or only applies to the next character, right? If you want it to apply to the whole thing cat, you have to put cat round brackets. That's B or C followed by AT, right? So that's bat or cat. This is A, so it either starts with an A or ends with an A. Right, so let's try that one out. A or A. Oh. I typed that in wrong? I did not. It probably has to be quoted. Sorry. Oh, there you go. Okay. So that matches because it starts with an A. That matches because it ends with an A. This should not match because it doesn't start or end with an A. Right, and of course, if you start and end with an A, it will also match. String that starts with ABC. I don't think that's correct. Every string that starts with AB. That's not correct, I don't think. Let me try this. I think that explanation is wrong. Let me try to. So for X, Y, Z. Okay, so the description on the slide says that matches anything that starts with A, B, C or ends with X, Y, Z. So this should be true. Now, I think this will actually match. My suspicion is that this actually matches something else. Match? Oh, it doesn't match. Okay, maybe it does really match this. All right, see, so does it also end in X, Y, Z? So 1, 2, 3, X, Y, Z. It looks like that's true. And of course, you can. It should also match anything that starts with X, Y, Z, has stuff in the middle, and ends in X, Y, Z. So it looks like that's also the case. Oh, okay. So here's how you force the group. So if you want to match A, B, C, Y, Z, or A, B, X, Y, Z, right? Then you can use the parentheses to group the sub-expression. Right, so this starts with AB, ends in YZ, and then has a C or X in the middle. Here's another example using, so if I group the expression in front and at the end, the two expressions, right? So starts with cat or tins is how you read this. This will be, this will match catnip and tin snips. What time is it? Okay. Now here are some actual examples of when you might want to use a regular expression, right? So you might want to use a regular expression to validate that something is a date. So for example, it's a date written out using all numbers, right? And furthermore, you might want to validate that the date lies within some certain range. So if I want to match all years between 1900 and 2099, right? How do you do this? Well, the date either starts with 19 or it starts with 20. So 19 or 20. Now, what about the next two digits? So the next digit, well, the next number is a digit, right? So square brackets, 0 through 9. Character has to be a digit, so square brackets, 0 through 9. You could also use a quantifier here. So you could write square brackets 0 through 9, brace 1 comma, sorry, brace 2. So exactly 2 instances of 0 through 9. Right. Now, what about the months 0, 1 through 12? Okay. So this one's a little trickier because you can start with, so the months either start with a 0. Okay. Oh, sorry. Let me do this again. So you either match 0 followed by the digits 1 through 9, right? So there is no month 0, 0, right? So 0 followed by the months 1 through 9, or the month starts with a 1, and then it's a 0, 1, or 2. So that one's a little trickier because it's a 2-digit month where the first digit might be a 0. And finally, the dates 0 through 31, it's similar to the previous example, right? I can have 0. So here are the dates 0 through 9, right? 0, 1, 0, 1, 0, 2, 0, 3, up to 0, 9, right? What about the days 1, 0 through 1, 1, right? So that's 1, followed by 0 through 9, or 2, followed by 0 through 9, right? Or you can start with a 3 and be 0 or 1. So you can see that the regular expressions, you can actually use them to match stuff, but they become very complicated very quickly, right? They're not easy to write by any means. So if you search online for regular expression, right, you want to learn how, you want to try to match something, you will get many results explaining how to use a regular expression to match something, right? So even matching a date, it's not exactly straightforward, right? It's easy to get something that seems to work, right? but it's much harder to get something that always works. Okay, so I guess we'll end there. Anybody have any questions about the lecture material? All right, anybody have any questions about the assignment? And anybody have any questions about, I guess, Bash in general, like getting it to work on your computer or anything like that? Okay, it doesn't look like there's any questions, so we'll end things there and pick things up on Thursday. Wednesday, tomorrow.